Assalamualaikum. My name is Muhammad Nasir Ahmad Sani. My metric number is 01DAT21F2026. Now I want to tell you about introduction drag coefficient. The drag coefficient is a fundamental parameter in vehicle dynamics that quantifies the aerodynamic efficiency of a vehicle. Essentially, it measures how effectively a vehicle moves the air. In a introductory context, you could explain that drag coefficient is a dimension number representing the resistance to motion because by the shape of the vehicle as it moves touch the air. Lower drag coefficient indicate better aerodynamic efficiency, meaning the vehicle encounters less resistance and requires less energy to maintain speed. Understanding the drag coefficient is crucial in various aspects of vehicle design and performance optimization, including fuel efficiency, top speed, and handling characteristics. Engineers and designers strive to minimize drag coefficient through careful aerodynamic shape of the vehicle body to improve overall performance and efficiency. Model A, Tesla Model SP85. Specification: power 310 kW, horsepower 421 horsepower or 416 bhp, rev at max power 5000 until 8000 rpm, torque 600 Nm, torque 443 lb feet. For dimension, length 4908 mm, width 2189 mm, height 1435 mm, track front 1661 mm, track rear 1699 mm, for wheelbase 295 mm.
Hi, my name is Kausun Jen and my matrix number is 01DAD21F2032. I will present my slide for the Toyota Vios. So the Toyota Vios have the power is 106 PS and the horsepower is 104 HP, 6000 RPM. And the max power for the Toyota Vios is 2000 until 5000 RPM. And the torque is 138 Nm. And the max torque is 4200 RPM. And the dimension for the Toyota Vios, the length is 4425 mm, width is 1740 mm, and the height is 1480 mm, and the track front is 1661 mm, and the rear is 1690 mm, and the last is the wheelbase is 2620 mm. Okay.
My name is Chia Ivan and my matrix number is 01DAD31F2009. I'll be talking about model C, which is Toyota Prius. So let's talk about specification. So this car comes with a 134 horsepower at 5200 RPM, the max torque of 143 Newton meter at 4000 RPM. So for the dimension, this car comes with 4460 millimeters of length, 1745 millimeters of width, and also the height is 1490 millimeters. And this car, the wheelbase is 2700 millimeters.
Now have to table Table 1 for data for velocity and aerodynamic drag. And table 2 for vehicle model A, Tesla Model S P85. The next slide, I will show you how to calculate.
I will go for the data for velocity and aerodynamic drag. Okay, and we have the data is shown as the slide is the V km per hour is 100, 120, 140, 160 and 200, and the V for the meter second is 27.778, 33.333 and 38.889 and 44.444, and the last is 55.556, and the dA is 249.741 and 359.827, and the 3 is 489.492 and 639.336, and the last is 998.963. And the worker model for the Toyota Vios is the front area I will got is 6.1596, and the drag coefficient is 0.0858. Okay.
So as you can see here, this is the table for the Model C, and we got the frontal area of 6.226 meter square, and also the drag coefficient is 0.085.
Now I show you how to calculate drag coefficient. Formula aerodynamic drag equal 1/2 P V square CD A. P is air density, V for velocity, CD for drag coefficient, and A which and height. Okay. So my first drag coefficient is 0.1682. Okay, now 2 and 5 formula step is same but different aerodynamic drag and velocity. My answer for 2 is 0.1683 0.1682 for 0.18 0.1680 and last 0.1682. This is graph velocity vs drag coefficient for model A. In part CX we have velocity and in part CY we have drag coefficient.
And my calculation for the Toyota Vios is dA equal to 1/2 PV square CDA, and I will get the result for the all result is 0.08 and 5. At the graph we can see at the part CX is the velocity and the part CY is the drag coefficient. So this the data I will collect it all is at the 08 point, is the data is 0.0858. Thank you.
So here is a calculation for Model C. I have used the velocities, 5 velocities according to the question wanted, which is 100, 120, 140, 160, and also lastly 200 km per hour. But in this in the calculation, we will be using the meter per second instead of kilometer per hour. So I'll be taking the 100 km per hour and I'll be converting it to become 27.778 meter per second. So in this calculation we will be using dA, which is drag force, okay, equal to 1/2 rho. For rho we get 1.225, and v square, v is velocities, so we just substitute the number of 27.778 into it, okay, and cd is drag coefficients, that is the number we want to find it. And for lastly, A is the frontal area. Frontal area we get it 6.226. So after we substitute all the numbers in it, it becomes 249.741 equal to 1/2 multiplied by 1.225 multiplied by 27.778 square. CD we just put there because since it's still unknown, and for A is 6.226. so after we calculate for it, we get it 2942.5 CD equal to 249.741. so we just since we want to find the CD, right, we just simply substitute the 2942.5 into the next side, and we become to 249.741 over 2942.5, and the answer is 0.085. so since then we just repeat the same step, okay, by just changing the number of velocity, which is equal to v, and we substitute it into the formula and we calculate again. Oh yeah, by the way, the dA also is changed according the velocities of the different of velocities. And lastly, we get all 5 of the numbers for the various speed. So here is the calculation for model C. I have used the velocities, 5 velocities according to the question wanted, which is 100, 120, 140, 160, and also lastly 200 km per hour. But in this in the calculation, we will be using the meter per second instead of kilometer per hour. So I'll be taking the 100 km per hour and I'll be converting it to become 27.778 meter per second. So in this calculation we will be using dA, which is drag force, okay, equal to 1/2 rho. For rho we get 1.225, and v square, v is velocities, so we just substitute the number of 27.778 into it, okay, and cd is drag coefficients, that is the number we want to find it. And for lastly, A is the frontal area. Frontal area we get it 6.226. so after we substitute all the numbers in it, it becomes 249.741 equal to 1/2 multiplied by 1.225 multiplied by 27.778 square. CD we just put there because since it's still unknown, and for A is 6.226. so after we calculate for it, we get it 2942.5 CD equal to 249.741. So we just since we want to find the CD, right, we just simply substitute the 2942.5 into the next side, and we become to 249.741 over 2942.5, and the answer is 0.085. So since then we just repeat the same step, okay, by just changing the number of velocity, which is equal to v, and we substitute it into the formula and we calculate again. Oh yeah, by the way, the dA also is changed according the velocities of the different of velocities. And lastly, we get all 5 of the numbers for the various speed.
Hi, Assalamualaikum. My name is Muhammad Tuafitri. My metric number is 018021F2029. I will continue at our slide, result and discussion. Based on the result, obtained model A has the highest drag coefficient than model B and model C. Point number 1, aerodynamic efficiency. The Tesla Model S P85, despite having a higher drag coefficient, is still very efficient because of its advanced technology. It's great for people who want a luxury electric car. The Toyota Vios and Prius are also efficient, with the Prius being efficiently good for the environment. Point number 2, performance and environmental impact. Car with lower drag coefficient perform better and are better for environment because they use less fuel. The Tesla Model S P85 is fast and eco-friendly, while the Vios and Prius are more focused on being fuel efficiency and reducing emission. So from this slide, we can see Model A, Tesla Model S P85 has the highest drag coefficient, and following by Model B, Toyota Vios. Toyota Vios has the second highest drag coefficient, and Model C, Toyota Prius. Model C has a third number of drag coefficient. Okay, for conclusion, the conclusion drawn from the drag coefficient result will typically involve understanding its impact on the object aerodynamic perform. A lower drag coefficient indicate better aerodynamic efficiency, meaning less resistant to motion through a fluid medium like air or water. Understanding the drag coefficient involves analyzing factors such as sharp surface texture and flow condition to optimize performance in various applications, from automotive design to sport equipment and beyond. This is our reference. Thank you.